And I'd like to welcome Eugene Bagashov here. We decided to do a Zoom call, and I wanted to talk to Eugene about a few different things here, uh, a range of different subjects that our viewers may not be used to. We're going to talk about mullets, Eugene's interior design ideas for gulag cells, Eugene's Sun blog, and how he is an X-ray bigot. He's uninterested in stars that don't emit X-rays, apparently, because he only seems to want to do a blog about our star when it's in a more high X-ray state, from what he said. Also about coronal holes and the current coronal hole drought. When I say current, the pun is intentional. And perhaps a little bit about magnetohydrodynamics, toroidal fields, and poloidal fields. What's going on, Eugene?
Hello, everyone. I'm, I don't know, like everything's fine, I guess, relatively speaking. So, what are we gonna discuss first?
So first, mullets. Mullets are a very distinctive hairdo. I'm sure you are familiar with it. It's otherwise known as the hair cape or perhaps the Wisconsin waterfall. It's when the hair on the top is it's when the hair in the back is significantly longer than the hair on the top and sides. So it was a pretty popular
Okay.
hairdo in the 1980s. MacGyver had a mullet. Lots of pro wrestlers had mullets. It's actually recently come back. Yes, mullets. And by the way, Eugene and I do not appear to have mullets. I've painstakingly avoided this hairdo for my entire life, at least
Okay.
since the
So,
90s.
is this a good thing or a bad thing? Is it like a sign of the end of the world?
Well, I think hairdos are cyclical like fashion, right? And solar cycles.
Yeah, it's like every 12,000 years you have the same haircut repeating.
The 12,000-year hairdo cycle. I'm not sure if that's present in the
Yes.
geologic record or not, but
I mean, it's obviously caused by cosmic rays because, as you love to say, there's a protons from Deneb hitting your brain.
yeah, all too true. And of course, now
So
for you viewers out there, I emailed Eugene because he's been recruited into the FGMA, which is the Future Gulagers of Minsk Association. And so I was also interested. Eugene, any ideas about interior design, like better home and gardens for gulags, and any ideas on that? Are they painted pretty colors? Are they all red inside because of the former Soviet status of Belarus? Or
yeah, I mean, the combination of red and yellow makes you hungry. So they're kind
ah,
of red and yellow. But I'm sure otherwise that I mean, I'm pretty excited to be a member because I've heard it's fun to stay at the FGMA, right?
that's right. Yes, I've heard the same thing. Now I'm not sure if they
So
have.
we'll see.
I'm not sure if they can cure your COVID in there via sauna and vodka or not, but it seems like a nice place to stay, but you wouldn't want to live there, I suppose. No, seriously though.
Why not?
Well, I've heard salt mines are much nicer in the summertime. So I did.
Yeah, we actually have a major potassium salt mines here.
Is it better than
Like it's
Borat's?
one of our biggest exports is raw potassium salt.
So you guys are a competitor with Kazakhstan then, because I heard
Um,
Kazakhstan's got some great
well, I'm not
potassium.
sure if Kazakhstan has a lot of it, but Russia does, and Canada, and
Ah,
maybe a couple of other places. But we're like a serious competitor in the world market in
well,
this regard.
fingers crossed that your potassium is better than Borat's potassium.
We'll
So
see.
so when the sun kicks up in its X-ray intensity, you start blogging about it. Tell us about that. Your blog was idle throughout the cycle 24-25 solar minimum transition time, or
Yeah, well, first of all, it's in Russian. Secondly, it's in another social network. It's sort of like a Russian clone of Facebook, which I
ah
spend more of my time in rather than Facebook. Even though actually recently I've not been able active there as well. Like I basically have only one friend who stays there, so I have no reason to be there myself. But anyway, so I created the blog in like 2014 when I became interested in this, electric universe kind of stuff. So it used to be more than just, event related blog. So I did quite a lot of research, like I've read a lot of articles and I did like literature reviews. Let's say I read a bunch of papers by Robitaille and I post like a huge, like very, very big post with like a bunch of quotations and references about Robitaille's theory, for example. Like I did in late 2014. Uh, and I used to do that regularly. Like every now and then, every maybe a week or a couple of weeks, I would post like a really, really big thing like that. But then, as I kind of was getting progressively tired, etc., it just degenerated into reporting about solar flares and CMEs and magnetic storms. So now I don't do literature reviews anymore. I just post like, okay, now we have like a moderate magnetic storm, and it may like last another 6 hours, and that's it pretty much. Uh,
I
so
see.
very, very brief messages like that.
I wonder if browser plugins would allow us to translate your blog so we could view it in English.
Let me look at it. I can actually send you the link, and
All right. We'll
like I think even like Google Translate can do that.
yeah, we'll
And
we'll put it in the links below the video in the description.
yeah, I don't think you need to be registered in this network to be able to read it. So you can.
Hmm.
It's kind of like an open thing.
Okay, and it actually displayed on the screen there too, so that's cool.
All right. Yeah.
So we actually have a solar
So
events.
that's it pretty much. Yeah.
All
And
right.
recently, yeah, I haven't been posting a lot because there wasn't anything to talk about really. I mean, uh, last major solar activity was in like September 2017, so that was like 4 years ago. Uh, yeah, so there you go.
So I think we're currently seeing a bit of a coronal hold drought. What are your thoughts on that?
I don't know. I don't think so. I mean, every now and then, every couple of weeks, we see like weak magnetic storms. So I don't see anything unusual about the present.
Well,
I don't know. Epoch.
Solar Cycle 25's field reversal process is really taking its good old time. If you look at the National Sunspot Observatory data, um, if you look at what it was doing magnetically 11 years ago versus now, it's completely different. It doesn't look anything like how far it was progressed at this time last cycle, relatively speaking.
I don't know. I haven't seen any analysis like that. Like one thing I can say about coronal holes now is that, well, currently we're just around the equatorial area of the sun. So I mean, just due to the seasonal character of our orbit, our inclination with respect to the solar equator. So that means that coronal holes are less geo-effective, because we're simply geometrically we're farther from them right now. You see what I'm saying? Like solar equator, if it's like horizontal, and our orbit, Earth's orbit, is inclined, right? So at one part of the year we're slightly to the north, so the northern coronal hole gets easier access to us, and half a year later we're kind of a little bit to the south, so the southern coronal hole can
Sure.
affect us more. But in the summer and in winter, we're like at the equator, we're like farther from both coronal poles. So that's
Yeah.
one reason.
But as the solar cycle progresses, we eventually get trans-equatorial coronal holes anyway. So
Yes, but we're not at this stage. Like, and we're not going to be there anytime soon. Like maybe 3 years until the next maximum. At least I would say.
all right. Anything else about your Sun blog?
No, I don't think so.
We should do a
I mean,
video.
but there are things that I kind of wished to research on my own, but I don't know, I don't really have the time or desire or energy to do. Like this issue of, Earth facing solar quiet, or this hypothesis that there's more sunspots entering the sun, well, like when viewed from Earth, I mean. So more sunspots turn towards us than turn away from us, which means that uh, being at Earth side of the sun sort of kills the sunspots, if you know what I mean, kind of wipes a little bit of them out. There was this effect in Monger's book.
Now that I'm not familiar with.
Heavens and Their Story, etc. Again, promoted by Davidson. So I wish to research that because I think, I mean, we have plenty of data. I mean, we have pretty much like pictures of the sun for every day in the last like 50 years. You just go there and look at it and count them. But I mean, obviously, it would take like a year to just do that. So I'm not sure if this is justified.
So that's I've got to look into that myself because I thought the Earth facing quiet effect was uh, the tendency for less and lower intensity X-ray flares to happen when a sunspot's facing Earth. Not that we'd have
Yes,
less
that's
sunspots,
what
but
I mean, but there is like a connected effect with sunspots themselves, that there are more sunspots turning towards us, like appearing on the western side, on the eastern side of the limb, than disappearing on the eastern. I mean, so sunspots disappear somewhere in between, appearing and kind of turning towards us and turning away from us. I mean, I'm kind of explaining this in a stupid way, but I hope it's understood.
I don't understand what you're saying at all. Uh,
Oh, all right. Well, let me try some different way. Okay, so it seems like sunspots tend to disappear when they are like facing the Earth. Does that make sense?
like at an Earth facing longitude. Yeah, I see what you're saying.
Yes, it seems to like wipe a little bit of them out. Um,
I think
so
that
there was three sunspots turning into eastern from the eastern limb, but when they reached center meridian, one of them disappeared, and only two of them left. The Earth facing disk. So this discrepancy between three appearing and only two of them remaining, uh, that's the effect.
well, what's the physics? What's the physics? What's the alleged physics behind this? Because
I don't know. I mean, that's the question. Well, firstly, we need to confirm that such an effect exists, because the only instance of it being reported was in like 1900, the year 1900, book by Maunder, Heavens and Their Story, or something like that. So, I mean, surely today we can have a much better analytical tools to, count all these things, the number of sunspots, their area, their magnetic complexity, or whatever, to figure out whether, Earth has any effect on this at all, firstly. Then secondly, there's actually a known phenomenon called like active longitude. So sunspots not only appear at certain preferred latitudes on the sun, right? Sort of like this tropical belt, roughly speaking, and obviously getting closer to the equator as this maximum progresses. But also, there are longitudes on the sun where sunspots appear preferably. So
interesting.
that's another thing which may be somehow connected or may not be connected to this Earth facing,
See, now I think Robitaille's theories about the sun explain the Earth facing quiet effect, um, and I think it's because
Yeah. By the way, this is another thing I wanted to talk about, is that the effect of observing, let's say, stronger flares or more flares at the limb, right, versus the center of the disk,
Mhm.
may actually be caused. That's a thing I thought about like 7 years ago, so it's not a new idea, at least for me. So it may be caused by this anisotropy of the emission of, the sun itself, if you assume that it's made of condensed matter. So what I mean is that, if sun, roughly speaking, is a crystal looks differently at different angles. So maybe when you look at the limb, almost like parallel to the surface, the emission is actually stronger than when you look like, like directly
Exactly.
downwards, which would be at the center.
I think that
So
explains.
maybe the same X-ray flare happening on the limb just looks much brighter rather than in the center, rather than being brighter. And I think it actually may be somewhat confirmed or debunked because we have various satellites which may theoretically measure this anisotropy. Like, let's say if you measure the same flare from
Stereo A, for example.
GOES and SDO, they may have like I don't know, certain amount of degrees difference that would be able to distinguish. I mean, if there is a how would you say it, directional dependence of emissive power.
Yeah, well, and this is a logical explanation for why the limb of the sun appears brighter in X-ray all the time too, because
Yeah, yeah.
if a sun, and it also explains why a sunspot is dark in color. It's very flat from the perspective. In other words, you're seeing into this very flat surface, and the light that wants to emit out of this very flat surface does not want to come out perpendicular to that hexagonal planar lattice structure. It wants to come out at an angle, as light would be emitted from a metal. So it sort of does seem
it's
to
an interesting idea for sure.
tie things together. And like I totally believe what you're saying there. I believe that the same X-ray flare, if it's from a sunspot in a directly Earth-facing longitude, that it's going to be brighter if it's measured, for example, from stereo A, most likely, because it's going to be enough degrees of difference.
I mean, it's a hypothesis, but the good thing is that I think we have enough instruments to actually verify or falsify it. You just have to do some work to do that.
Yeah,
That's the most unsexy part about it.
Look at the same X-ray flare from different instruments. I completely agree. Uh, Although, if it's a thing at like Lagrangian point one or the SDO, that might not be enough difference in angle to really notice a difference.
Yeah, I mentioned SDO. Well, SDO is actually in geocentric. I mean, geostationary. Well, geosynchronous.
It's in like orbit. A figure 8 orbit over the
Central almost
Pacific.
Geostationary, but not quite.
Yeah.
But really, we want to use something else. Like I'm just not sure if like SOHO or ACE even have tools to measure like X-ray flux and stereo even more so. Like I think.
Yeah, I don't think they do.
Well, they certainly have coronagraphs. That's their main tool, like that we use. But what else do they have? I don't know, to be honest.
Right.
Plus, they've degraded to such a degree that maybe they cannot be calibrated anymore. I don't know, like stereo B is not even working for like 5 years already or something.
Well, the magnetometers still work, at least.
Yeah, maybe. Well, there's that, basically. That's
so,
one
all
interesting thing to study.
So yeah, that's interesting. You're probably one of the like what, a dozen people in the world that actually have any concept about this Earth facing, like a plausible theory on the Earth facing quiet effect, and on why sunspots tend to emit more X-rays around the limbs than on Earth facing longitudes. I think it's going to be it's going to be a while until that is a little bit more widely understood. Part of the reason for making a video like this one, I suppose.
Well, I want to stress that I'm not sure this is the case in the first place. We need to confirm it and you just have to analyze a lot of observational data. But I haven't done this, so I cannot say for sure.
Do you think the solid body rotation? Do you think the evidence of the solid body rotation in the internals of the sun are evidence that perhaps the internals of the sun are made of solid metallic hydrogen, a theoretical substance that we haven't even made in a lab yet?
Well, again, you have to analyze how you acquire this, how you come up with this idea, come up with the conclusion that the internal layers of the sun rotate as a solid body. I mean, we only have like a very secondary or even tertiary means of concluding that through like I don't even know what they call helioseismicity,
I believe
which
that is,
is
yeah, I think that's where it came from.
super doubtful.
Yeah, I
So
tend to agree, but uh, just figured I would put that out there. I don't think we've ever talked about that one before.
yeah, well, as far as I'm concerned, the sun may be like a very thin shell, like 400 kilometers, or I don't know, maybe a few thousand kilometers thick, and it might be completely hollow inside. Like it may be mostly emptiness. Uh, like I don't see any evidence that it's not, right? I'm not saying it is. It may be very, very, very solid, and only like the topmost layer is sort of like a liquid slash plasma. It may actually be, I don't know, a solid wooden sphere.
It could have ice cream inside of
Uh,
it.
yeah, yeah, it may actually be very cold. Again, we know that, well, no, it's a sarcastic type of knowing that corona is much hotter than the sun itself. So maybe the temperature profile is inverted, so it's ice cold at the center and very hot at the edges.
Should we
So
talk?
maybe it's actually, yeah.
Should we should we talk about measuring temperature on a thing like a star from a place like the Earth when you've got extensive and intensive properties issue? There's another one Robitaille regularly talks about when you.
Well, he talks about entropy and gravity, basically. That's his issue with it. But yeah, I mean, temperature is. By the way, according to Robitaille, like the temperature of the photosphere is actually much higher than what we measure, like this 6,000 Kelvin that we measure. I mean, he says that it's more like millions of Kelvin. It's just that uh, primary means, according to Robitaille again, primary means of transferring heat on the sun are convection and conduction. So therefore, the actual radiation almost doesn't happen on the sun. Therefore, I mean, comparatively speaking, therefore, the temperature that we conclude exists in the photosphere from observing the radiation would be much lower than the actual temperature, right? So the sun is like very, very hot, but emits very little, from which we assume that it's much colder than it actually is, sort of. That's the Robitaille's idea.
I hear that. And there are lots of videos for you viewers. There are lots of videos on his channel about this. The Sky Scholar channel on YouTube. You can watch a bunch of different videos on there. It is interesting, and I think the condensed matter stuff. I've been recently reading about superionized helium. I'm kind of going down the list to find out what anybody's studied. And that is a thing. You can actually read about superionized helium, helium under great pressure. It acts like a superconductor with, zero friction flow and so on at these high pressures. So anything else? Anything else you'd like to talk about the sun? I just wanted to briefly touch on magnetohydrodynamics after that. But if you still want to talk anything else about the sun, we're more than interested.
Well, it's not like we were talking about anything specifically anyway, so I don't think so. I mean, we can talk about a lot of stuff, but there's no immediate necessity as far as I'm concerned.
Let's just briefly talk about the different fields here, the toroidal versus poloidal fields, because we've done on the channel, we've done multiple videos about that in the cosmology segments, and the different fields are, we're seeing more and more papers come out about this. For example, I just saw one a couple of weeks ago about how the output from galactic scale jets seems to be at high output rates when the jets are aligned with the galaxy's magnetic fields, an indication that perhaps some kind of a rotational precession may be responsible for the different levels of output by these galactic cores. All rotating objects precess, in other words, wobble like a top when they spin. And so maybe you haven't seen this one yet. I have it as an open tab on my phone. I can send you that later also, and we can include that in the description below the video if you've never heard of this. But it's a pretty recent one.
No, to be honest, I don't know what you're talking about, and I could not really follow your explanation, like what exactly are we talking about.
So galactic jets have a tendency to be like a perpendicular looking jet sort of a feature coming out of the cores of galaxies, where
Yes, yes.
the jets tend to be perpendicular to the galactic disk plane. I mean,
Yes.
they aren't always. Sometimes they're very skewed. In fact, the Milky Way galaxies seem to be quite skewed at a significant angle. But
Yeah.
there seems to be a relationship between the output of these jets and the alignment to the galaxy's overall magnetic fields. So I'll send you the paper after we're done recording the video. You can check that out at a later time, and we'll also include it in the link below the video. When this paper came out, we covered it like on a cosmology segment. We've got like 200 cosmology segments in our playlist now. YouTube.com/smashamash/playlists is where you can find all of our playlists. But just a brief explanation here: toroidal fields versus poloidal fields. Toroidal fields are like donut-shaped fields that tend to be around the equators of stars. For example, we live on one. The interplanetary magnetic field is a donut-shaped toroidal field. And there are also these cone-shaped poloidal fields, and there seems to be a relationship between them in that, to the extent that the poloidal fields overlap each other, the net effect of those is the toroidal field. And we also seem to see a relationship in stars and galaxies where the toroidal field will emit X-rays and the poloidal field will be in a dormant state, and vice versa. So there seems to be sort of like an inverse proportional relationship between the output of the galactic jets and the output of the galactic disk. When the galactic disk seems to be at a low output rate, we seem to see a high jet output rate, and vice versa.
Yeah, it's kind of makes sense, I guess. I mean, in general, toroidal and poloidal are just geometric concepts, right? They're essentially toroidal means like wrapping around, like tangential, roughly speaking, whereas poloidal means this sort of axial, if you like. Or you might think about it as vertical versus horizontal or something like that. So these are just like two different components that you can disintegrate a magnetic field into, I guess. So yeah, so it would make sense that let's say certain configuration of electric currents that produces magnetic fields may produce them a little bit more in a toroidal fashion. So there would be, let's say, a little bit more vertical currents producing a little bit more, these wrapping around toroidal types of fields, or there would be more circular currents producing more poloidal fields, more vertical ones. So that's, I would guess, I mean, the discrepancy here. So in the solar system, we have heliospheric heliospheric current sheet, right? Where some unknown configuration of currents inside the sun causes the poloidal magnetic field of the sun, which is in its turn moving through the plasma, interplanetary plasma, has to cause also the sort of horizontal, meaning along the equator, currents into the sun or out from the sun, depending on the cycle and magnetic polarity. So you have interplanetary magnetic field of arbitrary three-dimensional direction here and there, right? And but if it's okay, I feel like I'm going too far into the woods, so to speak. So
No, it's okay.
what I wanted to say is yeah, what kind of field you end up with depends on what kind of current pattern produces it, or vice versa.
Or what? Yeah, that's exactly what I was gonna say, because I have to say this: chicken and egg arguments in physics are everything. A lot of people get mad at me because they say that I'm putting forth a semantic argument, but typically, what what angers people in the realm of the electric universe theory is not really a semantic argument. It's because it's sort of important which came first, the chicken or the egg in physics. And is the uh, is the current aligning the fields? Is the field aligning the current? And ultimately, the answer is that we don't know. I'm trying to be reasonable about it, but
I don't think so. I actually think it's perfectly reasonable to describe it like, I mean, I think we actually had this discussion before, but anyway, I'll repeat my point from back then that uh, it's sometimes it's convenient to use electric current description, sometimes it's convenient to use magnetic field description, but principally they're equivalent. Yeah, so the question is which one is convenient right now for the whatever purpose we're dealing with. Like, if we're trying to describe acceleration of charged particles, then we have to work with electric currents because magnetic fields cannot accelerate particles themselves. Electric fields do. So we have to figure out what kind of induced electric fields we're dealing with. Like, let's say when we're talking about auroral currents, etc., etc. So we have to talk about electric current description, right? But when we're talking about, let's say, magnetic field of Earth, we have to work with magnetic field of Earth simply because we don't know what kind of electric current pattern produces this field. We just don't observe this current. So we have to rely on the second, so to speak, secondary product according to current approach. Electric current, approach, which is the magnetic field. But again, theoretically, they're interchangeable. So when we're talking about interplanetary magnetic field, it's produced by the sun, but we don't see the current that produces it. So it's much more convenient to work with magnetic field rather than electric current because we don't know what the current is, right?
I see what
In
you're
case
saying.
of the auroral circuit, we know what the current is because again, we're directly observing the particles that these electric fields accelerate. So why do we need to again rely on hypothetical like processes like magnetic reconnection and stuff when we have electric fields that we can clearly observe and measure directly that can accelerate these particles? Why do we need magnetic field approach? We don't in this case again.
All right. Well, I think I think I've pretty much covered up everything that I want to cover here. Is there anything else you'd like to add about Mullet's interior design of gulags, your sun blog, magnetohydrodynamics?
I don't know. I don't think so.
All right. Well, let's close it out then. And everybody, make sure you go subscribe to Eugene's channel. Make sure you become a philosopher by listening to what Eugene here has to say about philosophy. Is philosophy a thing, or is it just a philosopher?
I guess it's the thing. You can say, well, what is philosophy? It's something that philosopher does, right? So
Right, I would
why
think
not?
so. Yeah, it's got adverb and adjective forms and so on, right?
Yeah.
All right, so yeah, thanks for joining me, Eugene, and thanks for viewing, everybody.
Yeah, thanks for having me and I don't know, expressing the interest in whatever we're talking about here.
All right, we'll see you next time. And again, check links in the description. We'll put links about some of the things we talked about here, and we'll see you next time at here at the Smash News Network, least busted name in news, and you get a rare chance to see my green screen here for once.
Yeah, okay, goodbye.
Bye bye.